Okay, hello everyone. What we'll do today is we'll take a look at section 21H, which is the second derivative. Now let's go ahead and start off here. It says if the original function that you have is y is equal to f of x, then what we can do is we can always calculate the first derivative, which is what we've been doing this entire chapter. So if we take the derivative of both sides, then what we can come up with is y prime is equal to f prime of x. That's basically what we've always been doing when it comes to the notation regarding the derivative. Now, another notation that we want to also pay particular attention to is this notation. And remember that we said that if you write that, the way that you read it is dy over d of x. That's of course going to be equal to y prime, which is equal to f prime of x. Now, if we calculate what is called a second derivative, really what the second derivative is the derivative of the first derivative. So you're going through the exact same process of calculating the derivative, but not from the original function, but from the first derivative. So in other words, you have to take the derivative, you have to do the derivative process twice. So notice that if I take the derivative of y prime, I get y double prime. If I take the derivative of f prime of x, I get f double prime of x. Now, this notation here is going to be a little bit more tricky, and you just need to know how to say it and also know how to write it, because it is written very different from how you say it. We said that this was dy over d of x. This is the second derivative of y with respect to x. Okay, so it's very different. This is the second derivative of y with respect to x. Okay? So we can continue on. If we take the derivative of the second derivative, we'll continue even though this is the second derivative section. We'll continue on and we can actually take the derivative of the second derivative and come up with something that's called the third derivative. So this would be the third derivative of y with respect to x. Okay? And that's y triple prime and f triple prime. Now, once we get past the third derivative, in order to make sure that we know the number of times that we've taken the derivative of a particular function, since we don't want to have to count so many of these little dashes, what we're going to do then is we're going to put the number of times that we apply the derivative to the original function in parentheses. Of course, if we don't have the parentheses there, then it looks like y to the fourth, which is a completely different concept. So this here would be the fourth derivative of y with respect to x, which is then written this way and this way. And of course, we could continue on, and we could say that this would be the nth derivative of y with respect to x. Okay? Now don't get that mixed, these 2's here, these 3's here, these 4's here, these n's here, and don't misrepresent them as exponents because they're not exponents. They're specific and particular notation used to represent derivatives larger than the second and first derivative. So be larger than the first derivative. So be very careful about that. Now let's just go ahead and practice a couple of these just to make sure that everyone's okay with this. Let's just say, for example, that we have an original function. Let's go ahead and talk about this original function here. Let's say that y is just going to be equal to 6x to the fourth. Let's make it a little bit more complicated, plus 3. Okay, now if we go ahead and take the first derivative of this original function here, then of course what we will come up with using the power rule is just going to be 24x to the third. And the 3 will disappear because that is a constant. And if we take the constant rule, the constant will disappear as 0. Now, if we go ahead and take the second derivative of this original function, we have to take the first derivative and then take the derivative of the first derivative. So what that would be then would be 24 times it by 3x squared. So this case would be, what is that, 12, 1, 72x to the second power. Okay, so we could continue this. Let's just go to the third and then we'll stop there. If we wanted to find the third derivative of this original function, I'd of course have to take the derivative of the second derivative, which means then that this would be 72 times it by 2x raised to the first power, and I'll just write that as just 2x, and that would be 144x. Okay, so you could of course continue on until the nth derivative. You could do as many times as you want.